In this class, we learn about using parametric constraints, both geometric and dimension together. In the last 3 classes, we learned about geometrical constraint, dimensional constraint independently, and also in this class we do some exercise and also the how parametric constraint can be applied in the form of a function. So I will just open the AutoCAD and show you all these things. So AutoCAD is open, and there is another window here called the parametric. It is related to parametric, and suppose I click on this parametric, there will be a screen coming over here. You just see the screen. So here we can write the function and expressions. I will explain you with a drawing. See, in many drawings, the length, breadth are related. That is, in many cases they say length is equal to 2 times the breadth. And sometimes the boards, particularly boards, length are of different length are in relation to a particular length. Suppose the length of a bolt is L and the other bolt length will be 0.5 L, the other one is 1.5 L, etc. And also the diameter of the bolt is related to the head diameter. Diameter of the bolt, threaded bolt diameter is equal to head diameter. It is 2 times the head diameter. So in many cases, what we have to do is we have to draw one dimension and the other dimension we can give a formula so that it automatically assumes the other dimension. I will draw with a demo, you will understand it. So I will draw a triangle, a rectangle here, and I will dimension it. Dimensional constraint I will apply. Horizontal. Dimension constraint. Horizontal. And also vertical for this rectangle, we will apply vertical. Vertical. 2 dimensions are there here, D1 and D2. D1 is 223.8. I will round it off to say this one I will round it off to say 100. Okay. And this I will round it off to 200. So here the line is inclined, so we can apply the geometrical constraint so that it is always remains vertical. So apply geometrical constraint to this and become, and similarly apply horizontal constraint to this and this. So we have 200 here, we have 100 here. We can hide these things, hide all constraints. See, we have 200 here, 100 here. Suppose in our join, the length is always 2 times the width. Then what we can give D2, here I can give a formula. See, it is 2 times, this is D2. It is 2 times D2. Suppose we change this, automatically the other one also get changed. Suppose I make it 150, this has become 2 times D2. So D1 is 2 times D2. And also it is important to know that this D1 can always be changed. D1 name, you can give some other name, say length. Okay, you can say length. Similarly, D2 can also be changed. D2, we can always change it to width. See, it automatically assumes the value, because once you change it here, it automatically D2 is changed and here it assumes the value. So this is how the formula, it follows the formula. So only one step dimension, other dimension will be assumed. There is also one table here. I will show you that. Click it. See here, it has appeared here. We can change this to a value. See this, for example, I want to change this. So we can 125. So it gets changed. So this dimension is constrained. That means it follows this. This is a dependent variable. This is a independent variable, and this is a dependent variable. So that means the value of length depends on the value of the width. So like this we can apply the formula. And we can also apply like this, some fraction value also you can give here. See, for example, you want to do 1.2. So it is changed to 1.2. This is the formula notation in case of parametric. See, you should remember these are all only the dimension constraint. This is not actual dimension. If you want to dimension actual dimension, you have to do the conventional way, what we did last time. Like this, to dimension. Okay, this is how we can do. Similarly, the other one we can do. Suppose I change this 50. The dimension also you have to get changed. Or we can just move it, let us see where it can move. See, it can move. Okay. Similarly, so when you print, these dimension won't appear, only these dimension will appear. So I will change once again to show you repeatedly how it works. See, again this is also get changed automatically because and here I will just change the dimension properly so that it can take exact without offering to or change it. Let us see how it is. So we will change this. No dimension, I need not change the position. If you correct the dimension, it will automatically get changed. This is how we can use the functions to dimension the objects. Now I will erase this. Now this is about parametric. We do a few, just one example, not a few, just one example about dimensioning and applying the constraint to the parametric. So I will draw lines at random as I draw last time. I will make it, I do not make it horizontal, I will make it random. Yes, erase this, make it at random. Like this, like this. And this. Let me draw something. We'll dimension this. No constraint has been applied so far, so we can dimension this drawing. Now, first we will apply geometrical constraints. Let us see how we can apply. See, here we will apply coincident. Once again, 2, 3, 4. We have to click both the lines for coincidence. Or we can select the entire picture and apply coincidence. Then on that also we can do it. Now we will dimension this drawing. So first we dimension, then we will do other thing. Align dimension. See this, is also aligned dimension. Now we will give angles for these two. Okay, this we have not aligned. Okay, we will align this. To bring it nearer to that, takes that value. Because at the center midpoint also shows a red circle. It means if you click there, it takes only that half of this length. Now, we have dimension, and one more dimension left is the inclinations. This also. See. Okay. This is how we can dimension the figure. Now, we give angle, then it will be constrained. See, we give angular dimension, we can give an angle to this, and this, to angle, and similarly it has come out here. Okay, that will be no problem. Okay, you can see the angle. These two we can angle. Produced another angle. 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 This is how. So, here is one more. You can give anywhere, you can give here also, anywhere you can give. Let's see. Is like dimension constraint over constraint. Cancel. So we will leave that because it will be over constraint, so you don't dimension that portion. Suppose we want to make this angle and this angle equal. What we can do? Here it is 180, here it is 140. We can always click on this. This is angular 2. So we can click here. This is equal to angular 2, ANG 2. So we will give a different name. This we will call it as A1. This we call it as A2. When space is there, it will go inside. And this we call it as A3. And this we call it as A4. This we call it as A5. Limit here. Now we want to make this A1, this is an angle A1 equal to A2. What we do is, we simply make it equal to A2. So it has become the same angle. And similarly, we want to make this A3 equal to A5, let us say. We have to change it to A5. Let's take another shape like this. And now 67, this let it be, doesn't have a relation with any other dimension. And we have not dimensioned this length. Let us try to dimension this. Let us see what is going to happen. So this is angle A6, we will call it as. See, you shouldn't give the same name because it creates a reference dimension. So, okay, we'll say this as a reference. These conflicts is just a reference dimension. That is, it automatically assumes the value. So you need not, in creating this figure, You need not know this angle, it means. Once you start creating, automatically it assumes this angle. So what is the angle here? That it has given as 60. It has assumed. We are not going to, we cannot assign any other value to this. And drawing itself is generated by calculating all the other angles. So this is how angles can be equated. Similarly, dimensions also can be equated, let us say. So D1 we want to make it equal to D2. So what we do is D2, say it has taken thing, and D5 equal to D6, let us say. D6 has taken, and D7 equal to D8. Okay, and then any other things? Symmetry, we are maintaining the symmetry. And this is D4. And suppose we want D4 is 1/3, I'll say 0.25 of D, or D3 we can say about 4 times D4. So what we can say? Or we can say 3 times, or whatever we do. Let us say 4 times. No, it cannot be. The expression cannot be evaluated because the parameter in the expression results in invalid. So we can see how much we can change it to. Say this will say T4 into 3. No, it cannot be. Value element constraint. So you cannot change this and make it equal because some other dimension we have to remove. So let it be as it is, and we will try to change the dimension whether it works or not. Let us see. It has changed. Okay. Because we cannot relate this because it will constrain. Will not allow it to change this to D4. Therefore, shall I? Then, like this, we can dimension these drawings, and we can also make it horizontal whenever is possible. We have to check this whether it is possible or not. Horizontal. Suppose we maintain. We click on this. Horizontal constraint can be applied. It has become. And similarly, the other one. We have to check when it is not possible, it itself gives an indication. Menu will be taken as constant possible, cannot be applied. Okay. And this is equal to D8. And this angle, so here it has become horizontal. We will see this, we can apply horizontal. Cannot be applied complex. Then if you want to apply, what we have to do is, we have to remove this. Remove the dimension, then try to apply it. Let us see whether we can. Now let us see whether we can apply the horizontal constraint. Inconsistency existing, so it is not possible. Suppose the line is to be horizontal, you have to draw it accordingly, and then you dimension it. So here we have dimension, and then we are going to apply a geometrical constraint. That shows in some places is not possible. So we cannot apply in such cases. And this angle, I am not sure whether we can change this angle. This is 67. This angle can possibly this side is this and this angle. This horizontal. This is also horizontal. This angle can be apply angular dimension to this. Let us see. we can apply. So this we call it as angle 6, 7. Okay. Now we will equate. A7. It has become like this. Okay. Suppose I make it this. If we make it horizontal, we can apply horizontal. No, it may not take. It's not. So we can erase this and see whether we can apply horizontal. We can remove this and see. Now this one. Now let us see whether we can apply horizontal. So it has become horizontal. This will coincide somewhere here. And D2 and D, these dimensions. And this is equal to 306. This is also 306. And this has come to total length 700. And like this we can make the drawing. See where, shall we see whether we can apply horizontal here? It's not possible. And this dimension is not known to us. So this angle we can change if we want. So 90, that's good. Automatically this is also get changed. Okay, these sides are equal. This is not symmetrical. Okay, so like this I just showed you. Like this we keep on dimensioning it depending upon your requirements or the dimensional constraint. See here. There is, once again I put here, see he gives a table what are the dimensions we have modified. Say for example you don't want this dimension to be changed, you can get it changed. D6, you want 600, you can get it changed to 600. Okay, like this you can change it here. This value is this. D8, that is the value. D8 is equal to D7. D7 is somewhere here, the value. You can change here also the values. So this is how we can dimension. So now we have learned about parametric dimension constraint and then geometrical constraint, how to apply auto constraint and how to do settings. And whenever it is not required, we can manage to remove the dimensions. And also from parameter manager, this is this manager. We also know how to apply formula and how it appears in the formula chart, the formulas. So this is about the parametric manager. I will end this class now.